This is our home, the Milky Way galaxy, simulated in Python using Pygame. On screen right now is 2,000 stars that are being calculated in real time through code, physics, and math. In this video, I aim to show you the real physics behind these celestial behemoths and simulate an accurate galaxy on my potato laptop. So, let's go! Alright, so here's the game plan. Step 1, we gotta create the universe. Step 2, we gotta spawn in the galaxy. And step 3, that's it. Actually, there's no step 3, it's pretty simple. But to start, let's create the universe. So let's create a blank Pygame window and initialize a basic game loop to start to keep everything running. While I'm here, I'm also adding two things that are gonna save me a lot of headaches later. An FPS counter and delta time. Delta time measures how much real time has passed since the previous frame. That means the physics are based on time instead of frame count. So the galaxy behaves the same whether it's running at 60 FPS or 200 FPS. Alright, perfect. So now we have an empty universe. Now let's work on the actual galaxy. A galaxy is made up of a bunch of stars, so let's make some. This was done through a simple loop where each star was just stored as a few numbers. But I knew that each star would have properties like brightness, mass, gravity eventually, so I created a dedicated star class to make the coding easier. Now every star can store its own properties and make everything much easier to manage. Of course, a bunch of dots on the screen isn't a galaxy because we don't have gravity. To turn these dots into stars, we can rely on our boy Newton. The big man himself created an equation that basically says the closer a star gets to the center of the galaxy, the stronger the gravity will become. But there's a catch to this. If a star reaches the exact center of our galaxy, the equation will try to divide by 0, which would explode our laptops because, they can't divide by 0. So to fix this, some GOAT astronomers came up with the idea to replace the center of the galaxy with something called the Plummer softened potential. This just turns the center from a singular point to a small area, so the equation just never divides by 0. The epsilon, the little E symbol, smooths out the force near the origin, which prevents stars from being launched across the galaxy. Alright, so this is what the Plummer softened model looks like in code. Let's see what happens when we run it. And so our galaxy is currently collapsing at the moment, which isn't ideal. Technically we have gravity and the stars are going towards the middle, but since I gave them basically no sideways velocity, the stars are just falling into the middle, overshooting it, and then flying back out. This is very fixable, but before we can implement sideways velocity, we have to figure out how fast each star should be moving to stay in orbit. This is called the orbital velocity. To figure out orbital velocity, we need to do some simple math and physics. We can start with the equation for finding centripetal equation and rearrange that in terms of velocity. Then we just plug that into our law of gravitation and solve for velocity, which will end up giving us the equation for the velocity required for a circular orbit. We can type that out in code very simply, and because the velocity vector is always perpendicular to an object's position vector in circular orbit, the star starts moving around the center rather than moving towards it. Okay, great, that's amazing. We have the skeleton of a galaxy now, except one thing. If you've seen pictures of galaxies, you know that they aren't just blobs of stars. They usually come in organized shapes. In a galaxy, stars are much more concentrated towards the center, and their density gradually decreases as we move outward. This concept can be described mathematically pretty simply. This is called an exponential disk. Basically, sigma r at a distance r from the center and r sub d controls how quickly that density falls off. To put it simply, the farther we move from the center, the less stars we create. And just like that, our galaxy is no longer a blob. But if you look very carefully, this doesn't look like our home galaxy. The Milky Way has these beautiful spiral arms, which we need to implement. This is really simple to do with a logarithm. Basically, this equation tells us where a star should be placed based on how far it is from the center. We can use this to draw imaginary spirals and then put stars around those imaginary lines. And now, we have spiral arms. If we let our simulation run for a bit, we can see that the spiral arms don't actually stay there. The stars scatter very quickly and turn into a blob again. Okay, this next part is kind of confusing, but basically we added a rotating gravitational perturbation that nudges the stars towards the spiral pattern as they rotate. I'm not gonna lie, I don't understand the semantics myself either, so I'm half blindly copying this equation from a research paper I found, but this is the equation for it. But even after this, there's one more big problem. The farther a star is from the center, the slower we would expect it to orbit if the visible matter was the only thing that was there. But when we look at real galaxies, the outer stars are moving way faster than they should be. So where is that extra gravity coming from? Well, it's a thing called dark matter. So instead of putting all the galaxy's mass at the center, we're gonna give the galaxy a massive, invisible dark matter halo surrounding it. By the way, this halo is invisible and not actually rendered, but alright, that's amazing. We have the major physics fully working. I wanted to add some visual polish, so I added what's called a bulge in the center of the galaxy to make it look cooler, and I got pretty tired of looking at the galaxy from a singular point, so I made it 3D. I added some color variation between the stars, and boom, we have a galaxy. This actually took a lot of optimization to run on my potato laptop, so a good chunk of my time was spent there. But running with around 45 FPS is not bad at all in my opinion. Anyways, that's a really simplified version of our amazing galaxy. If y'all did enjoy, please make sure to like and subscribe. Until next time though, peace out.